Today, we're going to pull back the curtain and look at one of the most fundamental ideas in all of computing. We're opening up the digital toolkit to really understand how computers actually remember things. I mean, really think about it for a second. How does that happen? When you close a game and come back hours later, how does it still know your high score? When you log into your favorite app, how does it know it's you? It all comes down to one simple but incredibly powerful idea. And that idea is called a variable. Honestly, the best way to picture it is just like a container or a box. It's a little spot in the computer's memory where we can stash a piece of information that we want to use later. It's the first tool you'll ever use and probably the most important. Okay, so we have these digital containers, but how do they actually work? Well, to be useful, every single one of these boxes needs just two simple things. First off, every box needs a label on it, right? That's its name. This is how we find that specific box again when we need to get the information out. So, if we have a box to store someone's age, we'd probably just call it age. Makes sense. And second, a box isn't very useful if it's empty. It needs to actually hold something. And that something is its value. So think of it like this. The name is the label on the outside of the box, and the value is the actual thing we've tucked away inside. And here's exactly what that looks like in code. Age. That's the name of our container, our label. That little equal sign, it just tells the computer, hey, store this inside. And the number 22 is the value we're putting in the box. That's it, a name and a value. Simple as that. So we have our boxes and we know they need labels. But, just like trying to organize a messy workshop, there are a few simple rules for labeling them so that the computer, and you frankly, doesn't get confused. Don't worry, there are only 4 really simple rules to remember. First, a name has to start with a letter or an underscore. It can't start with a number. Second, you can't have any spaces, so username is a no-go, but user underscore name is totally fine. And finally, and this one's important, they're case sensitive. A variable named age with a capital A is a completely different box from one named age in all lowercase. Just 4 little rules to keep everything working smoothly. All right, we know how to make our boxes, we know how to label them correctly, which brings us to the next logical question, right? What kind of stuff can we actually put inside them? Are all boxes built the same? And the answer is a big, resounding yes. There are different kinds. Which brings us to this idea of data types. Look, you wouldn't store soup in a cardboard box, right? You need the right container for the job. Well, in the digital world, it's the exact same idea. Our containers are specialized for the type of data they're meant to hold. Let's just quickly run through the most common ones. You've got an int, which is short for integer, and that's for any whole number. A float is for any number that has a decimal point. An str, or string, is for text, anything from a single letter to an entire book, and you'll always see it wrapped in quotes. Then you have a bool, which is short for boolean. This one is super simple. It can only ever be true or false. It's like a light switch, on or off. And finally, a list is like a bigger box that's designed to hold a whole collection of other items inside it. Choosing the right data type is crucial because it tells the computer what kind of information it's dealing with. Okay, theory is great, but let's actually see this stuff in action. We're going to use our new digital toolkit to store some basic information about a student. So first up, we'll create a variable called name, and because Yash is text, it's got to be a string. Next, we make a variable called age, and we store the whole number 22 in it, which makes it an integer. See? 2 different boxes for 2 different kinds of data. Let's keep going. We'll add another variable, marks, and store 89.7. That decimal point is a dead giveaway. This is a float. Then we'll add isPassed and set it to true. That's our boolean, a simple yes or no answer. And now for the last piece of the puzzle. This student is taking multiple subjects. A simple variable can't hold all of them at once, unless, of course, it's a list. So we create a subjects variable, and it now holds 3 separate text strings, all neatly organized in one container. See how we've used the perfect box for every single job. Okay, so we've got boxes, we've got labels, we've got different types of data. You might be thinking, this is cool, but why does this really matter? Well, this is where it gets really exciting, because these simple, fundamental ideas are the direct foundation for some of the most advanced technology on Earth, artificial intelligence. I am not exaggerating. Every single sophisticated AI, every machine learning model that seems like magic, it's all built from the ground up using these simple containers. It all starts right here. Just think about it for a second. When an AI needs to learn from millions of images or text files, where does all that training data get stored? In variables, usually massive, complex lists. And when the AI makes a prediction, like identifying a cat in a photo, where does that answer go? Yep, into a variable. When engineers track how well the AI is performing, that accuracy score, say 98.5%, that's stored in a float variable. These aren't just for coding beginners. They are the absolute bedrock of AI.
So the next time you interact with an AI and it does something that just blows your mind, remember what's happening under the hood. Deep down, underneath all that amazing complexity, is a beautifully organized system of these simple digital boxes, each one labeled correctly and holding exactly the right kind of data. Which leaves us with one final thought. Could the most advanced AI on the planet even exist without them?